we discussed the last part of the chapter 4. Okay, we look into the synthetic rubber, synthetic rubber. Okay, so what is mean by synthetic rubber? They are elastomer, they are elastic and can regain their original length after being stretched and pressed. Actually, it's elastic now, elastic. Meaning that it will go back to original length after being stretched and pressed. Okay, they are synthetic rubber. So how is synthetic polymers or synthetic rubber produced? Okay, so it will produce through the polymerization process, okay, of hydrocarbon monomers obtained from the petroleum fractions. Okay, so let's see the property of natural rubber and synthetic rubber. So heat resistant, class, what do you think? Natural rubber, how is the heat resistant?
Low resistant to heat.
Low, no resistant, or we say it is less or lower. Okay. Cannot resist. Kelvin's one also actually is logic also. No resistance. Once you hit it, it will melt. Correct. But the synthetic rubber, okay, more heat resistant or high. Okay, very good. Next, hardness. For natural rubber, class, what do you think? The hardness of natural rubber.
Soft?
Okay, softer. Okay, softer. Meaning the synthetic will be harder. Okay, good. Now, ease of oxidation by oxygen. Okay, for natural rubber. Sorry. Okay. So, class, what do you think? Ease of oxidation by oxygen, easy or not? For natural rubber.
Yes.
Yes, easier, easy. For synthetic rubber, difficult, difficult. Okay. Next, resistant to chemicals and solvent. Okay, what do you think? Can resist or not?
It asks for what? I mean, like, does it ask easy to coagulate or what?
No, meanings any like oxidation, like chemicals or any solvent. Easy or not? It can resist or not?
Lower resistant.
Lower resistant or not resistant. Okay, low resistant means not able to resist actually. And okay, then this one you can say it resistant Okay, meaning it's not easy to react with chemicals. Okay, now elasticity. Natural rubber. Elastic or not? Which one is more elastic, class? Synthetic rubber or natural rubber is more elastic?
Natural.
More elastic? At least a natural rubber more elastic, right? Okay, how about the others?
Is it like how well it can extend to a larger length under sand wet or something?
Yeah. Okay.
Natural.
Everybody, you must remember. Okay, what is mean by elastic? Okay, elastic. Normally, we will feel that. Okay, let's say this is initial length, right? Okay, this is initial length. Okay, so elastic. A lot of us or students will feel that how long it can extend. Correct. If more, we feel it is more elastic. Actually, not the meaning of elastic. Okay, elastic means that it is able to extend, right? Okay, then using the same weight okay, or same force. Then elastic means that after you extend it, right? Okay, extend it. Then after you remove it, correct? So see whether it can return to its original position or not, original length or not. Okay. So if it can return to its original length like the initial one, like this, meaning that it is more elastic. Understand? But if it extend, right? Okay, quite long. But after you remove it, it stop at here. After you remove it, so actually it's not able to return to its original position or original length. So we call it is less elastic. Understand? The elasticity is not the ability you stretch it, how long it can be stretched. No. Understand? Elasticity is when you extend it and then you remove the weight or the force, you see whether it can return to its initial length or not. If yes, it is more elastic. If no, it is less elastic. Okay, you get what I mean? Okay or not, class?
Okay.
That is the meaning of elastic. Elasticity is can regain their original length after being stretched or pressed. Okay, this is called elastic. Okay, so meaning that natural rubber and synthetic rubber, what do you think? Which one is more elastic? Okay, remember here vulcanized rubber is a synthetic rubber lah. Actually, this one is more elastic. Okay, the natural one will be less elastic. Okay, both can be stretched, both. The natural rubber, it cannot return to its initial length. It can return a bit, but not able to return to original one. But the synthetic rubber normally can. So it is more elastic. Okay. Class, any question you want to ask? Is that okay? Or later we'll see some questions. So similarities. Natural rubber and synthetic rubber are good heat and electrical insulator. Cannot conduct heat and cannot conduct electricity. Okay. As well as easy to vulcanize to increase their strength. Okay. Okay. Now, let's see some of the example of synthetic rubber, their characteristics and their uses. Okay, actually, previously we have learned on this under polymerization already. So these are actually more to revision a bit. Okay, so first one, neoprene. Yeah, neoprene. Special properties: not flammable, heat resistant, it resistant to water, oil, and chemicals. So where can we use this? Tank lining for storing petrol and solvent, petrol hose, rubber pipes for gases and chemicals, wetsuits and wire insulation. All this, the lining actually. Okay, this one is under neoprene. Okay, next is thiocol. Okay, very resistant to oil and solvent. Okay, where we can use it? Tank lining for storing petrol and solvent and also petrol hose. Okay. Then SBR. Okay, this one I think you still remember, right? High resistant to heat and abrasion resistant. Okay, where we can use it? Car tires, shoe soles. Okay, conveyor belts and gasket. Okay, next is a silicone rubber. Okay, withstand high temperature. Okay, where we can use it? Rubber tube, cooking utensil, food storage products, adhesives and sealants, medical devices and automotive components. Okay, so under silicon rubber. Okay, then nitrile rubber, where we can see it is very resistant to oil and solvent. So for gasket, now engine hose, and gloves. Okay, discuss the uses of synthetic rubber and their effect on the environment. Okay, tire are one of the synthetic rubber products which is the largest waste and difficult to dispose of due to its non-biodegradable nature. It's the largest waste. Okay, and then difficult to dispose. Okay, so without a proper disposal system, used tire becomes breeding grounds for mosquitoes and pollute the environment, right? Okay, so used tire are also prone to fire risk as well as emitting fumes containing the toxic chemicals, right? And the nature of tires that are resistant to high temperature is used as decoration, especially in open areas. So you can see sometimes, you see they would use the tires and then you paint it and then use for gardening, right? Sometimes they use it because it is very resistant to high temperature, okay? Then used tire can also be recycled by converting them to rubber powder that can be used to make the rubber towels for playgrounds, rubber mats, and stadium tracks. Okay, that one also is you can recycle it. Okay, convert them into the rubber powder. So these are the two suggestions. You can reduce the pollution by the synthetic rubber. Okay. Okay. A1. Give another two examples of natural polymers that you know or you find out. Okay, you type out your answer. What natural polymers you have found? Okay, protein, starch, cotton. Okay, starch. Okay, what else? Others, cellulose. Okay, correct. How about the others? Protein. Okay, what else? Two. Any others? Example beside the one mentioned here? Okay, isoprene. Okay, isoprene. Isoprene is a natural rubber. Isoprene. Okay, hair. Okay, hair. Okay, any other answer? No. Okay. So you can choose any two now. Any two. Now, number 2, draw the structure formula and write the IUPAC name for the monomer of the natural rubber. Okay. So have you tried this? What is the name? Okay, you can write out the name. It's quite long, right? Okay, write out the name for the monomer of the natural rubber. Okay, so if you draw, I think you should be able to find, right? Okay, so two methyl built 1,3-diene. Okay, so this is a structural formula. Okay, so 2 methyl, okay, built 1,3-diene. Okay, everybody you check yours. Okay, we also call this is polyisoprene. Okay, but this one is the IUPAC nomenclature, IUPAC name. This one, this is the requirement by the question. Okay, now B, the tires of aircraft are made from the vulcanized rubber. So what is mean by vulcanized rubber? Okay, so what is mean by vulcanized rubber? I think you should be able to find from the notes, right? Okay, what are the keywords? Okay, cross links. Cross links of what? Sulfur atoms. It forms a cross links. Okay, between the rubber polymers. Okay, can I? So sulfur cross links is the keywords. Okay, so rubber producer when sulfur atoms form cross links. Okay, between rubber polymer at the carbon double bond. Okay, the keywords here: sulfur atoms cross links. Okay, correct. Now explain why the vulcanized rubber is more elastic. Okay, so more elastic, I explained just now already. It can extend, okay, and then it will return to its original length after the weight is removed, right? Then why it is more elastic? Okay, what have you write out, or what are the keywords that you have find? The presence of cross links. Yes, the key points you hear. Presence of sulfur cross links. Okay, what is the effect? Presence of cross links. Yeah, the key concept is correct. Okay, harder for the rubber polymers to slide over each other. Okay, very good, correct. Then, okay, it is not easy lah, okay, or harder to slide over one another. And then it will return, right? Returns to its original position after being stretched. Okay, yeah. Oh, correct. So Winnie had mentioned 2 points here, so you just add in another point. That is the return to its original position after being stretched. Okay, 3 points. Okay, huh? So yeah, the presence of sulfur cross links, okay, reduce the rubber polymers or rubber polymers to slide over one another easily. Okay, so the rubber polymers can return to its original position after being stretched. Okay. So this is how you explain why the vulcanized rubber is more elastic than unvulcanized rubber. Okay, huh? Now, C diagram shows the 3 types of material made from the different synthetic rubbers. Okay, so material X, what is this class? Material X. Can you type out your answer? What is material X? Yes, okay. Adeline, good. Is thiokol. Okay. Thiokol. any pronouns you like now. Okay, material wise, okay, swimming suits, right? Neoprene. Okay, very good. Neoprene. Okay, how about Z? Styrene, butadiene, rubber. Styrene, butadiene. Okay. Rubber. Okay, very good. So what are the type of XYZ? Okay, I already mentioned. Okay, state the spatial properties for each synthetic polymers. Okay, Tioco. So your marks here, material X, you have to mention that is Tioco first. Okay, so material X. What is the spatial properties for the Tioco here? Okay, this one I would like to ask. Tiffany, what is the spatial characteristics or property of Tioco here? Can you type out? Okay, next one, material Y. Okay, I would like to ask Michelle. Okay, and then material Z. Okay, material Z. What is the spatial characteristics? Okay, this one I would like to ask this Winnie Wong. Okay, Winnie Wong. Okay, X, Tiffany, are you able to find the answer? Okay, very resistant to oil and solvent. Okay, very good. Okay, correct. Very resistant to oil and solvent. Okay, good. Okay, how about Y? Michelle? Neoprene, what is the special property? Yeah, Michelle? And then next is Z. Styrene, butadiene, rubber. Winnie Wong, what is the special property? Okay, more resistant to water, oil, solvent, and heat. Okay. Yeah. Okay. Correct. Ken. And then it is not flammable. Okay. Neoprene is not flammable. Okay. You can add in also. Okay. Correct. Michelle. Correct. So. Okay. Then how about Z? Winnie Wong? What is the answer for Z? Material Z. Styrene, butadiene, rubber. What is the uses special property? Can you find the answer? Or I'll call this Kevin. What is the uses you get for Z, material Z? Kevin. Okay, high heat resistant and abrasion resistant. Okay, very good, Winnie. Okay, so you can write down. Okay, so there are three synthetic synthetic rubbers here. They have special properties. Okay, so remember it. Now, materials that play an important part in manufacturing a car. What are the effects towards environment if the material is not being disposed properly? Then suggest the recycle activity for material Z. Okay, so first you have to explain what is the effect towards the environment if the material Z is not being disposed properly. So just now we discussed few, right? So if you have found yours, okay, can you type out your answer? You can type in more than one if you want. What is the effect, class? Some, right? That's how. Okay, become breeding grounds for mosquitoes. Okay, correct. Okay, you can write down. Land pollution. Okay, can. Okay, what else? Beside that? Pollute the environment, right? Okay. What else, class? Only two? How about the others? Prone to fire risk. Okay, correct. Then if fire or it burns, what is the effect? You emit fumes containing the toxic chemicals, right? You can write also that one. Okay. Then, what is we go to the second part, suggest the recycling activity. What can we recycle? How can we do for recycling the material Z, class? What have you find for this answer? Recycle to decorate for open areas. Okay, very good, Winnie. Okay, beside that, how about Valerie? What have you right? Okay, reuse. Let me see. Okay, reuse the material as a flower pot. Yes. Okay. Convert into the rubber powder. Yes, can. Okay, this rubber powder, and then you can use it to make what? You can mention, make the rubber towels for great playgrounds, right? Then rubber mats, then stadium tracks, right? The running tracks. Okay, this rubber powder. Okay, Alice mentioned reuse the materials as the flower pots. Yes, like Winnie mentioned just now, right? Okay, decorate for the open areas as the flower pots also can. Okay, good. So you can find from here just now, huh? Okay.